Hello students, in our last videos we had discussed the characteristics of solids, liquid and gaseous state of matter. So all the things we can summarize as it is given in this table. That is, here the it has been compared, the different characteristics of solid, liquid and gases has been compared here. So here you see here the interparticle spaces. It is very small in solid, it is comparatively large in liquid, and it is very large in gas. Whereas interparticle forces, it is very strong in solid, weak in liquid and very weak in gaseous state. And nature, the solid state is very hard and rigid, whereas liquid is fluid, where gases are highly fluid. And compressibility, solids are that is, they can hardly be compressed, that is, compression is negligible, whereas compressibility is very small in liquid state and very high, that is highly compressible. Gases are highly compressible. And shape and volume, solids have definite shape and volume, liquid have indefinite shape but definite volume, and gases have indefinite shape as well as volume. Density of solid is very high, it is liquid is less than the solid density, and in gaseous density is very low. And molecular motion of or kinetic energy, so it is kinetic energy is very low in solid, it is comparatively high in liquid, it is very high in gaseous state. And diffusion, in solid diffusion is negligible, whereas in liquid it is slow, and in case of gases it is very fast. Now we'll discuss the change in state of matter. And first question is, why does the change in state takes place? It is actually because of the change in interparticle spaces and interparticle forces. One thing you know, interparticle forces are inversely proportional to interparticle spaces. More these spaces, lesser are the forces. And if solid is to be converted into liquid, the interparticle space have to be increased. And similarly, if a liquid is to be changed to the gas, the spaces have to be further increased. And one state of a substance can be converted into other by changing interparticle spaces. And they actually change interparticle forces of attraction. One thing, the process can be reversed also under suitable condition. That means what we have discussed, that means solid can be converted into liquid and liquid further can be converted into gases. And this one also can be reversed, that means from gas to liquid and liquid to gas also it can take place. So this changing of state of matter from one form to another is known as interconversion of state of matter. Interconversion of state of matter. Now we'll discuss what are the effects of temperature on change of state. And this interconversion of state of matter can be achieved by two ways. One is by changing the temperature, another is by changing the pressure. First of all, we'll discuss how by changing the temperature it can change the state of matter. For this one, we'll take the example of ice. We know that ice we can convert into liquid and gases easily. So for this one, we can do one experiment, and in that experiment we'll heat the ice, and we'll take one thermometer also, and we can put like we can take one beaker and in this beaker we will put some pieces of ice, and then we'll put one thermometer also, and then we'll give here one source of heat. Then we'll start heating it. If as soon as we are starting heating it, the temperature of this ice present inside the beaker will start rising. But when it will start melting, as soon as once the melting process starts, the temperature of the thermometer becomes constant till the whole of ice melts. And it is quite surprising that there is no increase in temperature, though the beaker is still being heated as before. The question is, where does the heat energy go? We can say, once the process of melting of ice starts, this one starts converting into liquid. The heat energy is now consumed in bringing about the change in state from solid to liquid. We can also say that the heat energy is used up to overcome the interparticle forces of attraction present among the water molecules in ice, and thus it is absorbed by ice without changing the temperature, and this is known as latent heat, which means that it is in hidden form as it is not visible. So now we are just going to discuss very important term, and that is latent heat. That is latent heat. First of all, we'll define this latent heat. What is this latent heat mean actually? So this latent heat means the amount of heat energy that is needed to convert 1 kg of a solid into the liquid state at its melting point temperature without any rise in temperature under atmospheric pressure. Students, you can pause the video and you can write it down.